Hi and welcome to this technical presentation on the ViBE product. ViBE is a VPN tunneling technology for VoIP, developed by VoIP UK and distributed in South Africa by Knowledge. In this presentation I will demonstrate the 4 key benefits of the ViBE protocol. I'll demonstrate voice multiplexing, quality of service, WAN optimization and redundancy. I'm going to explain the lab setup first before continuing to the live demo. My demo kit consists of a ViBE CPE customer router, a ViBE server, an Ethernet switch, an Asterisk IPPBX server, IP phone, and a call generator. The reason for using an Ethernet switch is so that I can demonstrate the functions of ViBE visually using software called Wireshark. The switch allows me to use mirrored ports. Trace points are between the ViBE CPE and server, as well as the ViBE server LAN interface. I've set up a dual link RAIN mode connection between the ViBE server and CPE. Furthermore, I set the link speeds to 300 kilobits per second in both directions. I specifically chose 300 kilobits per second because it is easier to flood 300K with RTP than 100 megabits per second. More on the RAIN mode later in this video. I use the IP phone as my control, and I use it in the QoS and redundancy tests as well. The call generator is used to generate RTP traffic. The Asterisk IPBX server has been configured with a music on hold channel, which both the IP phone and call generator can dial. My next step is to visually show what a standard G729 codec call looks like in Wireshark. I'll be using the IP phone first. My Wireshark filters have been pre-configured to save some time. I'm now dialing the music on hold channel on my IP phone. As you can see on the graph, in this case a G729 call with a 20 milliseconds voice quantum equates to plus minus 30 kilobits per second in bandwidth usage. This is on par with the calculations for a G729 call over Ethernet. On PPP connections like with the ADSL, the bandwidth utilization will be slightly less. Another key factor of a single G729 call is that the packets per second equal 50. Next, I will generate a single call using my call generator. I use an open source call generator called SIP-P. I also pre-made scripts to execute my SIP-P with the correct parameters and call count. I will now generate one call using SIP-P. Looking at Wireshark, we can see that my generated call has the same properties as a normal G729 phone call. The packets per second is also 50 as with the IP phone call. Next, I will be demonstrating the first function of ViBE, voice multiplexing. I will activate another graph in Wireshark. This will represent the actual ViBE tunnel traffic as seen leaving the WAN interface. This contains the multiplexed voice streams. The red graph shows RTP before ViBE, and the green graph shows ViBE tunnel traffic. Looking at the Wireshark diagram, we can see some activity between the ViBE server and CPE. This is the keep alive traffic sent between the two devices. I will now generate 10 G729 calls. By looking at the graph, we can clearly see that ViBE only requires 100 kilobits to transmit 10 G729 calls. Without the ViBE, we would require 300 kilobits per second, as you can see by the red graph. This is on par with the previous test, whereby 1 G729 calls equals 30 kilobits per second. 10 calls equal 300 kilobits per second. Another interesting point is the packets per second. Here we can see the voice multiplexing effect more clearly. 10 G729 calls would require 500 packets per second without ViBE, whereas with ViBE it only requires a constant 50 packets per second. In essence, if ViBE is not used, all routers and devices in the call path will have to route 500 packets per second. I will now generate 20 voice calls. Now, as you can see, 20 voice calls would require 600 kilobits per second without ViBE. Again, looking at the red graph. With ViBE, only 200 kilobits per second is required to transport the 20 calls across the WAN connection. Looking at the packets per second, we can see that ViBE still only requires 50 packets per second, when normally you would reach 1,000 packets per second for 20 G729 calls without ViBE. ViBE can achieve such bandwidth savings by removing the network overheads of calls beyond the first one. Only one set of network and transport headers is required to transport 20 calls in this case, using ViBE. Alright, moving on to the quality of service demonstration. I will start a copy process on my call generator. I will be copying a dummy file from my Asterisk server. I'm using Secure Copy or SCP to copy the data. Another graph will be activated in Wireshark to show the copying. The blue graph now shows the data copy. Here we can see that the copying is slightly under the actual ViBE tunnel traffic speed. This is because ViBE reserves 10% of the specified bandwidth for SIP signaling and so forth. It can be adjusted to suit the need of the particular network requirement. In this case, I left it on the default 10%. Looking specifically at the copying, we can see that the utilization graph is very linear. This falls into feature number 3 on my ViBE network list to discuss. It's not a main feature of ViBE, but rather a spin-off. Data utilization is much more efficient because of ViBE's QoS and windowing techniques. ViBE by default, using the default QoS policy, will automatically prioritize data packets smaller than 300 bytes ahead of larger data packets. This means acknowledged packets, etc. will get sent much quicker and not sit behind other data congestion. This has a positive overall effect on data transmission. Now I will generate 20 calls together with the data copy. The call generator is set up to ramp up the calls one by one. This allows me to better illustrate the quality of service. Here we can see how finely tuned ViBE's QoS subsystem is. ViBE will only shape the data traffic enough to allow for the voice traffic to flow. Data is still permitted to flow freely up to the maximum kilobits per second until the voice traffic stops. This all happens dynamically. I'll start an IP phone call as well to hear the voice quality.
Our fathers brought forth on this continent a new nation, conceived in liberty.
So, just to recap, there are 21 voice calls now active and data copying present on the link. There is also no loss of voice quality at all. ViBE's QoS system is much more efficient and dynamic on traffic queues than traditional QoS used on routers and switches today. Next up, I'll demonstrate redundancy and RAIN mode. Looking at ViBE's web interface, we can see that both ViBE tunnels are up simultaneously. I will now proceed to generate 20 voice calls, leave the data copying running, and also dial the music on hold channel on my IP phone. Once all this is running, I will disconnect the one WAN link and then both on the ViBE server. So let me set up the 20 calls on my call generator. You can see in the ViBE WAN GUI interface, you can see the calls ramping up. Now I will dial the music on hold on my IP phone. I will now disconnect one WAN link. As you can hear in the background, the voice calls and RTP is still running. I will now disconnect all links, and as you'd expect, the call would drop. The call is now silent, as you can hear. I will now reconnect both links. The RTP continues, as you can hear in the background, so the call just re-establishes without any interruption. ViBE's rain mode function allows the duplicate transmission of data across all the links participating in the rain mode logical link. Thus, in the case of failure, not a single packet would be lost, since the data is duplicated on the links that are up. ViBE can have up to 8 links participating in a rain configuration. This wraps up my ViBE technical presentation. Thank you so much for watching.